Hello, I'll be walking you through how to use driverless AI data recipes. And for this particular data recipe, we'll be importing hydraulic system condition monitoring data. And what you'll notice if we were to go look at the source of where we gathered the data from over at UCI ML repo, we have all these different data files for each particular sensor on the hydraulic system. And you could think of these data files as tables. And um, we have to do different data processing to put all of these files into a table and have each particular file's data be stored into the tables column. So we have a pressure sensor column, we have temperature sensor column, and so forth. And what we do typically is we'd end up writing a Python script, and then we would do that data manipulation on our local machine. But with driverless AI data recipes, we can go directly to the source using our Python script and then do the data manipulation within driverless AI and then import the transformed data into driverless AI. So that's what we're going to do. I'll be walking you through the code as well. Let's begin. So we're here in Puddle. I'm going to log in. We'll be using the deployment tutorial example. We'll start it. And while this is starting, let's walk through the code. So here's our data recipe, and we have this, what we're going to be using. We're going to be using data table, we're going to be using pandas, we're going to be using some H2O AI core system utils, the download module, for instance, we're going to be using OS, we're going to be using zip file, and let's walk through some more of the code. As we scroll down, we're going to see here that we have this OS path join, and we're using H2O AI cores config data directory followed by contrib relative directory, and then we choose the path to be the final folder name to be hydraulic. And this is a temporary path. So what we do, we use OS make directories to create it, and then we have the link. So if we go back up to the top here, what we see is we have this base URL. This is where we're getting the data from in the UCI ML repo. So we have the link, the base URL, followed by the actual zip file of the data. And then we call on the download module from H2O AI core system utils. We pass in the link, and then what we're saying here is this is the destination path. So once we're finished downloading the data zip file, we're downloading it to this location, and that's where we're getting from the temp path. And then we get the file, so that is a file object, and then what we're doing here is we're going to create an output file based on the name of our input file. So we're just saying file replace the zip with our own output name. And how I'm doing it here is whatever our target label is, we're going to choose to add into the final column of our data set. Let's add that target column into the data set name. So in this case, our target column is the cool condition Y. So what you'll see here is the file name has cooler condition. If we were using the valve condition, you'd see it has valve condition, and so forth. That just means we have all of our hydraulic system sensor data, and the last column, our label we're trying to classify, is cooler condition. and then we print the original file name and the output file name, and we choose our target column. We pass our target column into this extract hydraulic zip function. We pass the file and output file, and let's dive into that. So we have extract hydraulic zip. So what we're doing here is we're using the zip file module to extract, decompress this zip file. We're reading it, and what we do then is we have this load function that we're calling. Actually, before we do the load frame function call, we have this zip read this file that we're doing. So what this is allowing us to do is we've already specified we're reading the file, the zip file, and this is our zip object. So what we're able to do is whatever's in that zip file, we're able to call on the particular files within that. In this case, we're choosing the PS1 text, and we're able to read that. So then we read it, and that's file bytes object. And so what we need to do is we need to load that into a pandas data frame, because we're going to end up using pandas to do the data manipulation. So we have this load frame function that converts the bytes data to a pandas data frame. So we have this string conversion on file bytes object. We're saying it's UTF-8 data type, and we store that into a data file string object. And then this is where we use data table, because data table is very good at loading in all sorts of different kinds of data sources. And it's much faster at loading in data versus pandas. So we load in the data into this data table frame, and then since we're doing a lot of different data manipulation with pandas, we just convert the data table to a pandas data frame. We return the pandas data frame. And then we pass that pandas data frame into our main conversion. And what this is doing is it's taking every single line within our PS1 text file, and it's computing the average of that line. So if we were to look in that PS1 text file, you can think of each line as a row, and when you compute that row, what it says in the data set, if we were to go read on UCI condition monitoring of hydraulic system data set, it would tell us a cycle is 60 seconds, and what we find is every row is a cycle worth of data. So we get the average cycle data when we do this mean conversion for every single row. And then we just have the average for that row, and we compute it across all rows. Return that as a pandas data frame, and then we specify what our field name of that data is. And in this case, it's PSA bar, just an alias for PS1. And then we do the same data manipulation on PSB bar and PSC bar and so forth for all the different hydraulic system sensors. So we have pressure sensors, we have volume flow sensors, temperature sensors, pump efficiency sensor, vibration sensor, cooling efficiency sensor, cooling power sensor, efficiency factor, and then we have the labels that we're trying to classify. So we're going to import our hydraulic condition monitoring label data from the profile text file. That gets stored into a pandas data frame, and then what we're going to do is we're going to extract out each particular label. So we have a hydraulic cooling condition, hydraulic valve condition, pump leak, accumulator gas leak, and stable. And we're just extracting out these particular labels from each column within that profile data frame. And then what we're doing in the next phase is we're concatenating all of those data frames together, including our desired label as the last column, to create a new pandas data frame. So in this case, this pandas data frame has the hydraulic cooling condition, whereas this one has the valve condition label, and so forth. And then what we're allowing is the user's able to pass in what's their target label. So that is with the data that they're going to be using to train the machine learning model, what are they trying to classify, which label. So here they can choose the hydraulic cooling condition, valve condition, and so forth. And by default, I'll just have it be set to hydraulic cooling condition, but they can choose to change that if they want to do so. And then we come back, we return from the function, and now we have the output file that we originally passed into the function that we used to, we used pandas, actually we used data table to write to that CSV file, which we had the CSV file name specified in the output file variable. We returned that to Driverless AI. So let's go into Driverless AI. It should be on now. Okay. Okay, let's add. So there's two different ways to add the data recipe. We can do it through URL, and we can also do it through upload data recipe feature. So since we have it on our local machine, we're going to upload the data recipe. And we're going to say hydraulic. Let's upload it. Okay, looks good. Let's check to see, did it load successfully? It looks like it did load the columns, the fields, successfully. As we can see, these are the fields we were expecting. Our pressure sensors, our temperature sensors, our pump efficiency, efficiency factor percentage, and our label. A nice visualization for us. So I hope you guys found that helpful. This is how you use data recipes with Driverless AI.